In this video, we're going to do practical examples involving the chain rule. Now, we proved the chain rule in an earlier video, but now let's see how it works in a few questions. Suppose we were told that h of x is equal to this function given here. For 90% of questions, if we can just determine that derivative, we're going to be okay. So in other words, if we can just bring that 14 in front, leave the polynomial the same inside, subtract 1 from the exponent, and then determine the derivative of the inside, then we're going to be okay. However, that won't get us through every question, and it's still instructive to be able to determine what the inner and outer functions are. So if I look at the h of x given right there, and I say I need to think of that in terms of an inner and outer function, what I'll probably do is I'll say I'm going to let the inner function be the interior of that bracket, so 10x cubed minus 7x squared plus 3x minus 9. And then since the outer part of the function is blocked to the 14, I'm going to say f of x is x to the 14. Now, if g of x is 10x cubed minus 7x squared plus 3x minus 9, then g prime of x, using the power rule, is 30x squared minus 14x plus 3. And if f of x is x to the 14, then f prime of x will be 14x to the 13. So now we can say that h prime of x will be f prime of g of x times g prime of x. Well, we know that f prime of x is 14x to the 13, so we can say f prime of g of x is 14 times g of x to the 13. We know that g prime of x is 30x squared minus 14x plus 3. And so now all we need to do is substitute the expression for g of x in there, and we've got our derivative, which is equal to the answer that we previously wrote way up at the top of the page. All we did in that last step was we replaced g of x with literally g of x. All right, moving on to the next question. We can do a similar process here. Again, for the majority of questions, it'll get us through if we can just use that power of a function rule. For the majority of questions in this chapter, I should say, it'll get us through if we can do that. So 3/2 times x squared plus x, quantity to the 1/2, times the derivative of x squared plus x, which would be 2x plus 1. But let's think in terms of inner and outer functions briefly. And so what we'll do is we'll say I'm going to let y be f of g of x. The interior function g of x, the inner function, will be x squared plus x. The outer function is blocked to the 3/2, so I'll say f of x is x to the 3/2. Given the g of x expression of x squared plus x, I can say g prime of x is 2x plus 1. And given the expression for f of x equaling x to the 3/2, I can say f prime of x is 3/2 x to the 1/2. And now we can determine our overall derivative. It'll just be f prime g of x times g prime of x. Well, f prime of x is 3/2 x to the 1/2, so f prime of g of x will be 3/2 g of x to the 1/2. And we're multiplying by g prime of x, which is 2x plus 1. And now all we're going to do in this last line is sub in x squared plus x for our expression g of x. And when we do that, we get the same expression that we have up at the top. Okay. All right, moving on to our next question. We're now going to think of the chain rule in terms of Leibniz notation. And Leibniz notation says that dy over dx is equal to dy over du times du over dx. Now, there's a tendency on some students' parts to cross out these du's, think in terms of fractions, and say, well, we've got a couple of common factors there, so we can just say it equals dy over dx. I understand the visual desire to do that, but at the same time, these aren't factors, so crossing them out like that can look a little unsophisticated. So we'll just try to not do that, and we'll write it out this way, that dy, the derivative of y with respect to x, will equal the derivative of y with respect to u times the derivative of u with respect to x. Now, we have an expression for u that it equals 4 root x, so I'm going to change that to 4x to the exponent 1/2. And so now I'm going to say that the derivative of y with respect to x will be the derivative of y with respect to u, which is 8u cubed minus 6u plus 1, times the derivative of u with respect to x, which will be 2x to the exponent negative 1/2. Okay, so all we have to do now is plug in the values given. We're told that x is equal to 1, so that's pretty easy, but we don't know the value for u. But it won't be too hard to figure that out. We're just going to sub a x value in for 1. So we're going to get 4 root 1, which is 4. So what we're going to do, we're going to sub in an x value of 1 and a u value of 4. So we can say that dy over dx will be 8 4 cubed minus 6 times 4 plus 1. And then that will be multiplied by 2 times 1 to the exponent negative 1/2. Well, 8 times 4 cubed is going to equal 512 minus 64. Or sorry, this is 6 times 4, which is 24, plus 1. And then 2 times 1 to the exponent negative 1/2. 1 to the exponent negative 1/2 is just 1, so 2 times that is 2. And when we do that multiplication, we'll get 978. Well, that's one way of doing the question. But if we wanted to take a different method, what we could do instead is take this u expression of 4x to the 1/2 and literally just sub it in for u in the expression for y. So we would get 2 times 4x to the 1/2 raised to the exponent 4 minus 3 times 4x to the 1/2 quantity squared plus 4x to the 1/2 minus 1. Well, we would have 4 to the exponent 4, which is 256. And then we would have x to the 1/2 raised to the exponent 4, which is going to be x squared. Now we would have 4 squared, which is 16. And then x to the 1/2 quantity squared would just be x. And again, plus 4x to the 1/2 minus 1. Now, what we would get then, we would have, multiplying this 2 into this bracket, we would have 512x squared minus 48x plus 4x to the 1/2 minus 1. Now that's an expression for y. Well, let's get an expression for dy over dx. That'll be 1024x minus 48 plus 2x to the negative 1/2. And when I plug in an x value of 1, what we'll get is 1024 times 1 minus 48 plus, now 1 to the exponent negative 1/2 will be 1, so we'll subtract 2 times 1, and the answer will be the same answer we got a moment ago, which is 978. Now for this question, we're going to need to think in terms of inner and outer functions. We're told that h of x is equal to f of g of x. That means that h prime of x will be f prime of g of x times g prime of x. So we have right there the formula which we know to be true. let's just sub in an x value of 3 everywhere we have x in the first line of our solution. So we're going to say h prime at 3 is equal to f prime g at 3 times g prime at 3. Now this f prime g at 3 is a quantity unto itself, and this g prime at 3 is a quantity unto itself. The question is kind enough to tell us exactly what g at 3 equals and exactly what g prime at 3 equals. G at 3 is 12, g prime at 3 is 9. So we can say that what we really have is f prime at 12 times g, times 9, the number 9. So one more time, g prime at 3 is 9 from here. And g of 3 is 12 from here. So we're left with f prime of 12 times 9. So what does f prime at 12 equal? The question's kind enough to tell us it equals 11. So that first quantity is 11, the second quantity is 9, and 11 times 9 is 99. And there's our final answer. And for our last question here, we'll do the chain rule. We'll say k prime at x is equal to 8 times x cubed minus 2 times x cubed plus 3 quantity to the 7. We've dealt with the outer function. Now let's deal with the inner function, and we'll need to use the quotient rule for that. We'll say low d high minus high d low over low low. Now this question is asking us to evaluate that at a x value of -1. So k prime at -1 will be equal to 8 times. Now -1 quantity cubed is -1. So we'll have, oh sorry, and this is a 3, little typo in that earlier. There's a 3. So this x cubed value right there, if x is -1, that'll also be a -1. And then everywhere I see x cubed, I'll put -1 because -1 quantity cubed is -1. But everywhere I see x squared, I'll put +1 because -1 quantity squared is +1. So we get -1 plus 3 times 3 minus negative, and again, that's a 3 right there. Had a couple little typos there, but -1 minus 3, not in the typed part, just in my handwriting. And then 3x squared will be a 3. And all of that is over -1 plus 3 quantity squared. Okay, so -4 over 2 is -2. So we get 8 times -2 quantity to the 7. -2 quantity to the 7 is -128. Now up at the top, we have -1 plus 3, which is 2. 2 times 3 is 6. We've got -1 minus 3, which is -4. -4 times 3 is -12, but we have that subtraction there, so we're really adding it. Downstairs, -1 plus 3 is 2. We're squaring 2, so we're getting 4. So that fraction is 18 over 4, or in other words, 9 over 2. So we have 8 times -128 times 9 over 2, which is equal to -4,608.